Okay, so this first section we're going to kind of breeze through real quick because it's like very, I don't know, straightforward. I think you guys shouldn't have too much trouble here with this. So we're going to look at this explain 1 here, okay, again on page 140, and it says corresponding parts of congruent figures are congruent. Okay, and that's a mouthful, right? But what does it really mean? Well, it means if two figures are congruent, then corresponding sides, or another word for corresponding, you could say matching sides, okay, are congruent, and corresponding angles, or like matching angles, are congruent. Okay, so for here, example 1, we're told that triangle ABC is congruent to triangle DEF. Okay, that's a piece of information we're given, and we want to find the given side length or angle measure. Okay, so here are pictures of the actual triangles right there. And let's see here. For letter A, it asks us to find the length of DE, segment DE. So I look over here, okay, and I see segment DE, right, is blank. So we don't have any measurement given for it, all right? But what can I say that it matches with, Keegan? What do you say?
It matches with the same figure over there.
Yep, so what side does it match with over here? AB, exactly right. And so we can say DE has what measure then?
2.6.
Yep, 2.6 centimeters. Okay, very good. And yes, good. You do want to use units. If you're in a context, if the problem gives you a context, do keep that context. Use the units, okay? Very good. Later on, if you guys ever take calculus, for example, you know, sometimes you can mess up an entire problem. But if you still get the units right at the very end, you get a point for that. Okay, which is like, you know, it might not seem like a lot, but every point counts on that AP test. So I tell my calculus students all the time, if there's units, make sure you keep them. Okay. So yeah, 2.6 centimeters. Now Keegan, okay, you probably just eyeballed that, right? I'm assuming you looked at DE, like it probably matches with AB here, right? Is that what you were thinking, basically? Yeah. So here's something though. If you have trouble with that, there's a very easy way to determine what side DE matches up with, and it goes right here in the congruence statement. Okay, if you identify DE here in the first triangle, or the second triangle I should say, it's DE and E are the first two letters. If you then look at those corresponding letters over here, the corresponding letters are A and B, which are the exact sides, right, or the exact endpoints of that segment that we matched it with. Okay, so what I'm trying to show you here is that this congruent statement not only says the triangles are congruent, but it also has all of the corresponding parts listed for us. Okay, so for example, angle A in triangle ABC is in the first position here, so it must be congruent to what over here? Anybody? So, okay, I'll pick someone. Patrick, what do you say? Angle A, according to this statement, is in the first position, so it has to match up with angle D. Exactly right, okay? Angle B matches up with angle E, angle C, and angle F. And then likewise the segments. BC matches up with EF, and AC matches up with DF. Okay, so when I come down here to angle B, okay, Drew, what does angle B have to be congruent to according to my congruence statement here?
E.
Angle E, which is?
65.
65 degrees. So there you go. Okay. The book has us reading through a whole bunch of like stuff here, but I'm just like, I don't know, it seems kind of silly to do all this weirdness when it's just so easy, right? So straightforward. So yeah, it's that simple. Congruence is a congruent statement is a very powerful statement. It not only tells us the figures are congruent, but it also tells us all the matching parts. Okay? So, we're actually going to skip going over any of this stuff right here, except for I want to jump over here to, page 141. I apologize. So I want to jump over here to the bottom. We're not going to do the your turn stuff because it's, I don't know, I feel like it's so straightforward. It seems kind of just too easy for you guys. But let's get into something that's a little bit more tricky here. So again, the setup is, for example 2, triangle ABC is congruent to triangle DEF, and I want you to find the given side length or angle measure. Now you can see we got some X's and, well, just some X's and Y's thrown in here. So let's see here. So for this first question, we're asked to find side AB. Okay, and so Tanner, any ideas here about how he could like start going about trying to find AB? Yes, so AB must equal DE, and again, because we have that AB in the first position there and DE is in the first position, so what would be the equation that we write? There, Tanner. 3x plus 8 equals 5x. Okay. Very good. And why don't you go ahead and solve it for us there, Tanner, too? So what will we do? Okay, so what'd you do? What were your steps, though? So yeah, x is 4. Okay, so subtract 3x from each side, right? We get 8 equals 2x, yeah, and then what? Divide by 2, so you get, yeah, x is 4. So our final answer then, so the length of AB is 4. That's our final answer? 4 centimeters. Okay, so AB is 4 centimeters? Oh, inches. Oops, sorry. So AB is 4 inches then. We're done? No, we're not. Okay, and so Tanner, I know I was kind of like playing along there with you, and I apologize, but I do this on purpose because oftentimes this is exactly where students stop. They see an equation they set up, they solve it down for x, and they're like, oh, I'm done, I got an answer. X is my answer, so 4 is what I get for the length of AB, but it is not. Tanner, so what do we still have to do here? Yeah, I got to plug it back in, right? So plug it back in where? Yeah, 3x plus 8. So it's going to be 3 times the 4, right, plus the 8. So 12 plus 8, 20 inches is our answer, not 4, okay? So now I'm sure that you guys have seen that. You'll never make that mistake ever again. I'm sure about that, positive that won't happen. But if it does, well, at least now I can say I told you so, right? So there it is. Yes, 20 is our final answer for A, B right there. Okay, so be careful about that, though. Don't, make sure you're answering the question that's being asked. We're asked to find the length of AB. AB is 3x plus 8, so you have to plug that x back in. Okay? All right, very good. We'll try one more here. We're going to try and, okay, so over here on letter B it says to find the measure of angle D. Now, I'm not going to do the work here because I don't have the picture anymore, so instead we'll flip back and we'll just do angle D here in our little space down here, okay? It's kind of unfortunate that I had to change the page there, okay? So let's go to, so Mary, what will we do here to find angle D? What do you say? Okay, and again, how did you know that 6y plus 2 had to equal to 5y plus 11 there? Yeah, okay, the angles are corresponding, right? D is in that first position, A is in that first position, so that means they must be congruent. Great, okay. And solve it for us here, what do we got to do? Okay.
You get y plus 2 equals 11.
Okay.
Then you subtract 2 from both sides, and you get y is 9.
Y is 9, okay. And so 9's our final answer? No. No, right, okay, good. So let's
plug it back in.
Plug it back into what? The 6y plus 2, okay, so 6 times the 9 plus the 2. Okay, whoops, I don't know why I put a parenthesis there, I'm sorry. So that's again angle D, and I'm running out of space. But anyway, 6 times 9 plus the 2, that's 54, plus 2 is 56. And what should be the label for that? Inches? What are we measuring here, Maria? What's this? So if you go back here, it's asking us for the measure, let me scoot this over here, there we go. The measure of angle D. Do we measure angles in inches? Yeah, that's right, it's degrees. It's degrees. It's degrees. Okay, and so there's the, off the screen there, we go. So measure of angle D is 56 degrees. Okay? Alright, so this one I do want to make sure you're okay with, so let's have you guys go ahead here and try number 6 and 7 for the your turn there. Okay? 6 and 7 for the your turn. Okay? Give those a shot. Okay? Just to make sure you've got those okay. Yeah, okay. all those are equal. I'm sorry. What was the first when you went to solve? What did you do there?
Subtracted, or,
See that? Okay. Very good. You can keep working. That's okay. I can see. Just bring this with me because I'm freeze.
Oh, okay, I was gonna say, there you go, very good.
I want to check that. So from this, I can see it right here. From here to here, this steps. What did you do to go from here to here? To your equation. Good. I got all done there. Still working on that. Okay, good. That's good. Key. Got it. Good.
Got it.
Very good. All right, so looking good, guys. Just a few little algebra errors here or there, but that happens. Okay, so let's see here. So, Zishan, what'd you get for number 6?
35 centimeters.
35 centimeters. Good for the length there. Excellent. And let's see, let's go to Shannon. How would you get number 7? What'd you get?
I got 98 degrees.
98 degrees. That's right. There you go. Okay. All right, very good. So any questions on that stuff? Pretty straightforward, right? All right, so we're going to move on then to another section of the book today, continuing in from some of the stuff we talked about yesterday with interior and exterior angles of a triangle. So let's skip on to page 313 now. Okay, page 313. All right, you can see, actually, there's the activity we did yesterday, right at the end of class after the test. This is their way of animating a tear in paper. All right, very nice. You can see it. Okay, right? That's what we did, though. We drew cut-out triangles, all different kinds, put them all together, and made that nice 180-degree angle. Okay. And so we kind of then, came up with the idea that, well, it looks like, if all of our different triangles, right, add up to all those angles add up to 180, then chances are the sum of the angle measures of a triangle is 180 degrees. Okay? And in fact, that is the case here. And so we're actually going to take a look at a little proof. Oh, you guys thought those proofs had gone away. No, proofs are still around. Okay? So we're going to tackle this one right here. Okay? So if you look, we've got a little proof for us to do. So we're given the triangle here ABC. Okay, and we're trying to prove that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. And we're going to try and fill in some of these blanks here. Okay, so first thing we're going to do is they have us, and this is kind of a weird step for a proof. Okay, well they say, okay, we're just going to draw a line L. You can see it right there in the picture, right, through point B that's parallel to AC. Okay, so if these two things are parallel, we can put the little marks in there, remember that? Okay, little arrows to show that they're parallel. Okay, so there's that. Now, this next step here, it says, step 2, the measure of angle 1 is going to equal the measure of angle what? So there's angle 1. What other numbered angle up there must that equal? Yeah, Tanner? 4. Okay, so we're going to say 4. Tanner's right. We'll talk about the reason why here in just a second. And then let's see here. Angle 3. So there's measure of angle 3. What other angle must angle 3 be equal to? Yeah, Hunter?
5.
Yeah, so 5, right? Okay. So now, why? Evan?
Don't think this is, it's either corresponding or alternate, crap, it's removed.
Okay, you're on the right track.
Alternate
Yes.
Something, alternate something.
Alternate something. Yeah, so they're alternate, right, because they're on different sides. So if we think about there's parallel lines, right, cut by a transversal here, okay? These are on alternate sides of the transversal. So it's definitely... Maria? Oh, yeah. Alternate, alternate. Is that what you're going to say, Maria? Yeah, that's right. Alternate interior angles, okay? So, yeah, so, and I'm just going to put, alternate interior, I'm going to abbreviate here, angle theorem if you want to, or if you just put the word alternate interior angles, I like that too. Okay, alternate interior angle theorem. So, yeah, they must be congruent. See? So, good job there, guys. That's right. Okay. And the next one here, okay, well that's, okay, clearly the measure angle 4 plus the measure angle 2 plus the measure angle 5, we see that, those three angles, well they have to, add to make a straight angle there, so then that means they must add up to equal 180. But then if you notice here, some things change. We still have the equals 180, we still have the measure of angle 2 there, but measure of angle 4 is replaced, and so is the measure of angle 5. So Michael, what's yeah, we're using a substitution that's our reason. Okay, we're going to substitute in here. And then, Michael, can you tell me what are we substituting in, Michael? So for angle 4, what did we substitute in here?
We substituted angle 1 for angle 4 and angle 3 for angle 5.
There you go. There you go. And like that, it's done. We proved it. 1 plus 2 plus 3 is 180 degrees. So there it's been proved. Okay. Not too painful, right? I mean, we've had worse, I think, so that wasn't too bad there. All right. So now it's proved. Now we have it for sure, okay? This is something that was proved, right? All right, so let's turn the page. Okay. It actually turns out, right, that there's an interior angle sum rule for not just triangles, but also for other polygons, quadrilaterals, pentagons, hexagons, heptagons, octagons, so on and so forth. We're going to hold off on this activity for another unit much later, okay, when we talk about polygons. So we're going to hold off on that right now. We'll come back to that later, though. So don't worry about that right now. We're going to come to it, okay? And so we'll skip over that section for now, and we'll move on to page 317. Okay, still sticking with triangles for right now. So just to be continued in that section, okay? We'll look at that. All right, so we just talked about interior angles. And all the interior angles of a triangle add up to 360 degrees. Or, sorry, 180 degrees. Now we're going to look at exterior angles. So an exterior angle is an angle formed by one side of a polygon and the extension of an adjacent side. Okay, so let me just pause right there because that's a lot of words, right? So here's our polygon. It's a triangle, right? You can see the interior angles right here. And if we extend one side like this, then the exterior angle is this obtuse angle you see right there. Okay, it's this exterior angle. Okay, it's the angle formed by one side of the polygon and the extension of an adjacent side. So it's from this side to the extension of the adjacent side right there. That's that angle right there. Okay, that's the exterior angle. Okay, and so we could also draw, exterior angle right here, for example. And there's also like an exterior angle like right here, for example. Okay, and there's even another one right here, right? We could potentially draw one right there as well. Right? There's kind of two exterior angles at each kind of vertex there. Okay. So, let's go through these steps here to kind of look at this. Now it says it has us using a straight edge to draw a triangle, but we're just going to go ahead and just use the picture they gave us right here because, well, it's already handy. So why not, right? Okay. So, here we have a triangle drawn for us with an exterior angle already constructed. Okay. We know the sum of the measures of the interior angles of a triangle, right? So angle 1 plus angle 2 plus angle 3, the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 has to be what, Melissa? 180 degrees. You got it. Okay? Now, in addition, if we look here at angle 3 and angle 4, what can we say is going to be true about angle 3 plus angle 4? Let's go to Jonathan. What do you say, John?
They're going to be 180 degrees.
Yeah, 3 and 4 also have to add to 180. Why, John? What's?
Because they're like.
What's one of our vocab terms? If two angles add to 180 degrees, that means they are
Corresponding.
not corresponding. Yeah, Evan.
Supplementary.
Supplementary. Supplementary. Remember that? And then the other one is the 90 degrees, and that's Yeah, complementary, right? So there you go. That's so supplementary. Also, we can call this a linear pair too, right? There's two of them that add to make a straight line, so linear pair also. Okay. So, what can we then say? What can you say about the measure of the exterior angle and the measure of its remote interior angle? So this is a little bit tricky here, but let's take a look. All right. If we take 1 plus 2 plus 3, that equals 180. But if we also take 3 plus 4, that is also equal to 180. Both of these equations, what do both of these equations have in common for their angles? What angles do they both have in common, these two equations here? Angle 3, right. And so they both have angle 3, and they also both add up to 180. So what must we know? What must be true about angle 1 plus angle 2 and angle 4? That's right, Shannon. They must equal angle 4. 1 plus 2 must equal 4, right? If both equations have 3, so the only difference between these two equations is that this one has 1 plus 2, this one has angle 4. Okay? That means these two things have to be equal. Must be. So that's our conjecture. Maybe the measure of angle 1 plus the measure of angle 2 has to equal the measure of angle 4 there. Okay? All right, now, these things were referred to as remote interior angles, and I guess I'll go back and highlight that again. So, the exterior angle that we're talking about right here, okay, these two angles inside the triangle are called the remote interior angles, right? That word remote means distant or far away, right? When you use a remote control for your TV, you're controlling the TV from far away. Believe it or not, there used to be a time when you'd have to get up off of your seat and go turn the knob on it to turn the channel, okay? But now we have remote control, so we can control the TVs from far away, right? Or if you go, to like a remote or remote location, that means you're far away from things, right? When you're in a remote location. So remote interior angles are far away. The two angles that are far away from that exterior angle there. Okay. So sure enough, we go to the exterior angles theorem here. The measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles, just like Shannon said there. So that is an actual theorem. Okay, so we're going to look through a proof here, okay, of that. And it basically just follows kind of the logic that we were using there. Okay, so back to that original picture, okay, by the blank, measure of angle 1 plus measure of angle 2 plus measure of angle 3 equals 180. So what was the name of that theorem that told us that the three angles in a triangle add up to 180? I'm going to have to pick someone else here besides Evan. Let's go, So Keegan, what was that theorem? Do you remember? We just talked about it. Previous page or two. Don't remember?
No.
I know, right? We just learned it. It's kind of like, it's very self-explanatory. It's not like
Triangle sum.
triangle sum, exactly right, yeah. And it kind of makes sense, right? Okay, triangle sum. We're adding up the angles of a triangle. So by the triangle sum theorem, I'm going to abbreviate the word theorem because it's not going to fit. Okay, angle 1 plus angle 2 plus angle 3 equals 180. Okay, also, the measure of angle 3 plus the measure of angle 4 has to equal what, Elizabeth? 180 as well, and it gives us the reason because they're supplementary and make a straight angle. By the substitution property of equality, then, the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 must equal what? What can I put in here, Elizabeth? I'm going to have you keep going with that one. What can I put in for those blanks? Okay, so let's go back to what we just said here. We have these previous two statements. 1 plus 2 plus 3 is 180. 3 plus 4 is 180. So what can I say? 1 plus 2 plus 3 must then equal 3 and 4. Exactly right. Right? So the substitution there is we're plugging in place of the 180. Okay, subtracting the measure of angle 3 from each side of this equation leaves what? And let's go to Shannon. What do you say there? If we subtract the measure of angle 3 from each side, what do we have left then? Uh-huh. Oh, okay. Measure of angle 1 plus the measure of angle 2 is what? Yeah, equals 4. Yeah, all right. Yeah. No, that's it. Yep, that's it. Sorry. That's right. You just subtracted measure of angle 3 from each side, so we left with that. And so lo and behold, we've proved it, right? This means the measure of an exterior angle of a triangle is equal to the sum of the measures of the remote interior, right? This is true in general. Notice we did not put any numbers in here for 1, 2, 3, and 4. It's just kind of generic, symbols and stuff, but it ended up working out that, yes, 1 plus 2 is equal to 4 there, remote interiors. Okay, so let's see this in practice. Okay? So number 9, it has us looking at to determine the measure of each exterior angle and then add them together. What can you say about their sums? Let's look at this picture right here and see if we can come up with some exterior angles. So let's do this one first, right here, this exterior angle right there. Okay, so let's start that one. Okay? So from what we just learned, all right, Lindsay, how can I go about trying to find this exterior angle? What would I need to add up?
You have to add up over 40.
First, the line.
So sorry, say it one more time. It would be 140, you're saying? Okay, 140?
The line.
How'd you get that?
Because it's calculated 180, the linear pair.
Ah, okay, so you got this by doing 180 minus the 40 there. Very good, okay? Using our exterior angle sum, okay, so using our exterior angle theorem we just talked about, right, we would add up the two remote interior angles. Well, we know that one's 60, but we don't know this remote interior, so we can't check to see if 140 is right. I mean, Lindsay's correct. It has to be right because 180 minus 40 gives us 140 here. How can we figure out this third angle, though, missing from our triangle? So, yeah, what do you say there, Hunter?
And you have to do like 60 plus 40 plus like x equals 180.
Aha, right. So we don't know that missing one, so we can do 60 plus 40 plus x equals 180 using that triangle sum, and then subtract out the 60 and the, so that's 100 plus x equals 180, and so then x equals 80. So then that means that angle's 80. Okay? So let's check to see that our exterior angle theorem that we just talked about, right over here, I know you can barely see it right there. Okay, let's see if that does work. So 60 plus 80, does that give us 140? Does it? Yeah, it does. Okay, so there it is. Okay, but anyway, that's good. So good job there, Lindsay. Thank you. All right, let's go to... All right, Adam, let's pick another one here. Adam, how about we do this exterior angle? What's that measure going to be?
That's going to be 130.
130? How'd you get 130?
It says 180 subtracted 60.
Okay, so... Right, it'd be 120. 120, yeah, 120. That's okay. 120, that's right. Very good. 120, yep. Or we can also add 80 and 40, right? 80 plus 40, the remote interiors for that one. 120. Okay, good. And then last one here, Mary, what's this exterior angle right here? 100. Okay. So here you go. And again, it's 60 plus 40, or you can just 180 minus the 80 there. Now, it says here, determine the measure of each exterior angle and add them together. So if we add all those together, what are we going to get here, Elizabeth? So, yeah, 360. 100 plus 120 plus 140 is 360 degrees. Okay? I don't even know if there's too much to explain there. Okay, but that's their sum, 360 degrees. I guess the explanation is partly the work there too. Okay. I feel like I've kind of already hit this, but anyway, we'll look at number 10 too. So according to the definition of an exterior angle, one of the sides of the triangle must be extended in order to see it. How many ways can this be done at any vertex? So for example, how many different ways can we make an exterior angle at this vertex? I can see there's one way, but how many different exterior angles are there at this vertex? Let's see, Melissa, what do you say there? How many exterior angles could I draw? I have one drawn, and that's from extending this side. This side right here. So how many exterior angles would that make then? Well, so I see what you're saying. So be careful though. It's just two, right? The exterior angle has to have one side of the triangle and then extended side as its other side. So there's one there and then one there. So each vertex would have two, or a total of 6. Okay, right? So a total of 6, because there could be 2 there and there'd be 2 there. Okay. Now I know we didn't talk about hexagons. Okay, but hexagons, I'll go ahead and give it away. They have 6 sides. So if a triangle had 6 exterior angles, anyone want to hazard a guess? How many exterior angles would a hexagon have? What do you think, Elizabeth? A hexagon has 6 sides. 12, exactly right. So yeah, so any vertex can ever have 2 exterior angles. So it would be 12 exterior angles for the hexagon. And again, we'll look more at polygons later unit, but I figured we could probably answer that question here now too. Okay? All right, let's move on to some actual problems then with some like variables and things. Okay? All right. So let's see here. Mason, letter A. We want to determine the measure of the specified angle. So we want to find the measure of angle B. Okay? Problem with that, though, right, is that we've got 5z minus 2 here, and we have no idea what z is yet. Now, granted, they show us right here already it's going to be z equals 21. But how can we go about setting up this problem right here? Any ideas? How can we relate these things to maybe write an equation and solve for z?
So you could add them together to equal 45 because 145 plus the measure of angle C also equals 180.
Okay.
The measure of angle C plus A and B equal 180.
Okay.
So A and B would equal 145.
Exactly. This is this exterior angles theorem. So these are your 2 remote interior angles. These together must add up to be the 145. So you just set up the equation like that. 2z plus 5z minus 2 equals 145. Okay? And so combine like terms, right? 7z minus 2 equals 145. Add 2 to both sides. Divide by 7. So z is 21. Okay? So is our answer 21 then, Mason?
Now you have to plug it back in.
Right. Very good. Mr. Myers trying to trick people again. Mason's on his toes, though. He's got it. No problem. Okay? 5 times 21, 105. Minus 2, 103 degrees. So there it is. Okay? Rather than you guys doing all of these, let me just go ahead and have you try. Go ahead and you do letter B. Just go ahead and do letter B in the space there. I'm not going to have you do those your turn ones. Just go ahead and try it, letter B. Set up your equation and then solve. Skip steps, just be careful. Okay. Which thing here? Is this what's this? Is this supposed to be equal to? Ah, I see. You're stuck. I see. Okay. So we want to find the measure of 3x minus 8, right? It's an exterior angle. And we talked about the measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles. So that means that would be equal to that plus that. Yep, good job. So that's correct. But what's the angle what angle do we want to find the measure of? PRS. Yeah, exactly. Maria, you got it? Stuck? Okay, so what are we trying to find the measure of? That angle, right? Okay, so we have to set up an equation though, because we don't know what x is. So we gotta find x first, then we plug it back in, finding the p. So what's the relationship we set up here? We have an exterior angle. We have these two remote interior. How do we relate those three things? Yeah. Exactly. The exterior angle is the sum of the two remote interiors. You solve that. Good. Okay. So let me just pick someone. Let's go to. All right. So John, what'd you come up with here for letter B?
I said that the measure of angle of PRS was 108 degrees.
108. What'd you get for x?
I got 44.
44.
That's wrong.
Okay. Thank you, Keegan. Yeah, so I think you're set up, I'm assuming you set it up correctly, yes? 90 plus x plus 2 equals 3x minus 8?
Or I added another x.
Ah, okay. So we, remember for the exterior angle here, exterior angle is equal to the sum of the two remote interiors. So all you have to do is just do 90 plus x plus 2 equals 3x minus 8. Okay? And then you solve for the x. So there's your work right there in your answers. Okay? All right. So yep, that's the end of it. So I'm going to get you guys started on your homework here. Yes, we're going to have homework from both sections, but it shouldn't be too terrible. At least I hope